The largest perfect square that'll go into 405 is 81. It goes in 5 times. And then the product rule for quotients tells us that we can split up that multiplication into separate square roots. So we've got square root of 81 times the square root of 5, and that's going to give us 9 times the square root of 5. Now, second option here, if you didn't recognize that 81 is the largest perfect square that goes into 405, well, we could do a prime factorization. The smallest prime that'll go into 405 is 3. And it's going to go in, let's see, 135 times. 3 will go into that again. 45 times. 3 goes into 45 15 times. And 3 goes into 15 5 times. To stop when the other is also a prime. And so square root of 405, we would have square root of 3 to the 4th times 5, and apply the product rule for radicals. You want to be careful with this next part. You don't want to see a mixing of these two in the end. That square root of 3 to the 4th is the same as 3 to the 4th to the 1/2, and we still have that times square root of 5 part. And multiply those exponents, you're going to get 3 squared, and you simplify that 3 squared as 9, and again we still have that times 9 square root of 5. We can check that with decimal approximations on the TI-30. Square root of 405. Close the parentheses here. We're getting about 20.12 something. Whereas if I do 9 times square root of 5, close the parentheses. Sometimes these decimal approximations may not line up exactly in the last digit or two, but in this case, we're seeing exactly the same decimal approximation. This is not the answer that we'd be looking for. That's an approximation. We're looking for an exact answer. And so the 9 square root of 5 that we had here in either method, that's what we're looking for.